So you may have seen some examples of Prolog code where you see some exclamation points in different places. So that's called the cut symbol, and we'll actually talk about what cut does now. We're going to write a function that's going to replace all the odd numbers in a list with the atom odd. It's going to remove zeros, and it's going to replace even numbers with half their value. Okay, so this will be a recursive list procedure. So first off, in our base case, we have the empty list is going to just be the match with the empty list. And instead of a period here, we're going to put a cut symbol. We're going to make it a rule with just a cut. And what that does is that cut ensures that we stop searching for a solution if the list is empty. So what this says is, okay, once you get to this point, the rule either passes or fails. So if you pass in an empty list, good, we unify with an empty list, and we don't need to try anything else. It's not going to work. Also, if one of these two lists is non-empty, but the other one is, we'll continue going. This won't stop it because it won't match that rule. So if we have an empty list in both places, we know we're good. We don't need to look anymore. So now, what if we have a 0 as the first element? So now, here we have a list with 0 and a tail. And we know if that's the case, we want to go through the rest of the list applying all these rules, but the 0 we don't care about. We're going to throw that away. So now we're going to put a cut here. And what this cut says is, if you've matched the head of this rule, if there's a 0 first, don't consider anything else. Just keep going with this rule. And we'll make a recursive call on the tail to get T1. So this cut below stops searching if the first element is 0. Now, notice though that we're not stopping calculating, we're stopping considering other options. If this fails, then our rule is going to fail, even if there's other rules below that will give us a solution, because this being matching 0 means that we're going to proceed down this rule. This rule, the first thing in the body is a cut, meaning stop, we're done. We don't want to look anymore. That means if you match this head, this is the rule we want to match. This is the rule we want to go with. We're going to check to see if we have an even number. We're going to do something with the head, and we're going to do something with the tail, and then put them back together. Now we don't want to put a cut here because we have to check what h is. So 0 is h mod 2, means h is even. Well, if h is even, I know what I want to do. So I'll put a cut here. And h1, we're going to divide h by 2, and we're going to do a recursive call on the tail. So this cut stops searching once it determines the head of the list is even. And you'll notice this rule would work or would succeed if h was 0. However, we would never get there because if h is 0, it would match this rule first. We have a cut, we would never consider this rule. So if you reject the solution you get going down this path, it's going to fail. You'll get the solution on that path, that's it. There's nothing else it can find because it won't go further once it sees a 0. Now, this is the case where we have an odd number and we're going to replace it with the atom odd. Now we actually no longer care what the head is. And the reason is it's not 0, it's not even, therefore it's an odd number. So I'm going to put the atom odd in front of the result of the recursive call on the tail. And you'll notice there's no cut here because I know this is basically anything else. It's not empty, it's not 0, and the head is not even, so it has to be odd. So we don't need to check if it's odd here. So let's add a few rules or a few facts about animals. So we have a warm-blooded rule, and we have warm-blooded cats, dogs, and chickens. We have a 4 legs rule for dogs and cats, and we have a 2 legs rule or fact that says that chickens have 2 legs. So I'm going to write a rule, mammal 0M, and for purposes of our discussion, we're going to say something is an animal if it's warm-blooded and has 4 legs. So let's consult. Actually, I don't think it looks like we didn't test our previous rule, so let's do that real quick. And let me put this in a list. And so you'll notice it removed the 0, so that rule did work. Okay, so now let's look back at our mammal rule. So mammal 0 is going to succeed if M is warm-blooded and has 4 legs. So let's ask, what's a mammal 0? A cat and a dog, and that's it. It gives us false because once it finds dog, it can't find anything else. So it'll try chicken. Chickens are warm-blooded, but then this clause fails for M equal chicken. Let's add 2 hard-coded rules. We'll say bears are mammals and dolphins are mammals. So now bears are mammals, cats, dogs, and dolphins. Okay, and those hard-coded rules will sort of help us see, or the hard-coded facts will help us see how the cut works. So now I'm going to make a new rule that's just a copy of the previous one, except that I'm going to add a cut. So when it gets to this rule, I'm going to put a cut immediately following. So for mammal 1, so for some reason it didn't like that. I'll save it again. We'll consult. So mammal 1 is bears, cat, dog, and that's it. So unlike mammal 0, where we had dolphins, dolphins is excluded. And the reason is bears, we get to bears, fine. That's because we have a fact, bear succeeds. But then we say, give me an M where M is warm-blooded and has 4 legs. So in this particular case, we have a cut, and that means don't look at any other rules. However, notice we still generate dog and cat both because cats are warm-blooded and they're 4 legs. When we fail this rule, it'll go back, but it doesn't go all the way back to the start of the rule. It tries to find something else that's warm-blooded, and it'll find dogs after it finds cats. And cats and dogs have 4 legs as well, so they succeed. So this cut says don't look at any rules below this one, but it'll return multiple solutions for that particular rule. So now let's move the cut, and we're only going to consider, or we'll move the cut to after warm-blooded. Now what this is going to do is say once you found something warm-blooded, don't move forward. So when I consult and say mammal 2, I get bears and cat, and that's it. I think that should just be singular. Same for dolphins. So you'll see we just get bears and cat. Again, bears is a mammal because we've said that that's the first thing it approaches. Then we get to this rule and it says, okay, M is a mammal if M is warm-blooded. Well, it finds a cat. So then we have a cut. The cut says, okay, good. You're on a roll. M is cat. Keep going with just that. And then once we determine that that's a mammal, there's nothing else to do. there's no other facts that would generate additional things because we've already said cats have 4 legs. So essentially at this point, once we get here, this cut says whatever M is, that's what we're going with. We're not going to consider any other possibilities. Now this could be a problem. So let's say that sharks are warm-blooded. And if we consult that rule, now only bears are mammals because, or at least they're mammal 2s, because once it gets to this rule, the first thing it unifies M with is shark. Sharks are warm-blooded, great. Then we have the cut saying don't consider anything else but sharks here. Do sharks have 4 legs? No. The rule fails. It doesn't find any other additional solutions. So now let's do one final rule using this same pattern, and let's put the cut at the end. Whoops, we know what mammal 2 is. How about mammal 3? Bear and cat. So this time the rule succeeded even though sharks are warm-blooded, because sharks are warm-blooded but they don't have 4 legs, so we never get to the cut. Then we look at cats. Cats are warm-blooded, they have 4 legs. Then we hit the cut, so now we're done. Okay, so that's how the cut works. So one other thing I can do is I can make a rule that takes anything here and then say a cut. And then if I put fail here, this means nothing is a mammal 4. So no matter what I get here, it succeeds because this will match any parameter I give it. Then I have a cut, so I'm not going to consider anything else. And this says fail. This means fail the rule. So when I consult, say mammal 4, there's no mammal 4 because no matter what I put here, it fails. Now you can abuse cuts and fails, and there's also another thing called repeat, where the repeat generates a backtracking point and then the cut removes it. And so that you can kind of use this to sort of, or I should say misuse this to sort of create loops and things like that. But it's best to avoid that if at all possible. You start winding up with code that's very similar to an imperative language. You're not really using the logic language appropriately. But it's just something to be aware of. And cuts themselves are not actually a purely logical constraint, so they're not what's considered pure Prolog. But cuts can make our code more efficient by saying, look, if I get to this point, I know I'm on the right track. Don't backtrack. Don't consider anything else. Just keep moving forward. So cuts are helpful. Typically with a base case, it's always good to put a cut. And your code should work without the cut. It's just it'll work more efficiently with the cut. And then one exception to what I just said, though, is here's a case where since I did cuts everywhere else, in this last rule, I can assume that this is sort of an else case because everything has a cut once it succeeds. And this would be the case where only one rule you wanted to match. You could put a cut in each rule once you've determined that's the rule you want to consider for that particular input.